Hello, I'm Carlos Rosso Suarez, and this is the CRS channel. I'm going to continue with physics problems and kinematics, and we're going to complete problem 10. Okay, we obtained the expressions for the velocity, these two, and the position, these two, for the falling body, taking into account the air resistance. And from this expression, then we obtain these two. We obtain the respective expression for the acceleration. And we, from there, data table was elaborated, here was developed. Here we assume certain values for k. We have as constants the value of the acceleration with gravity, the initial height from which the falling body is let go, and first we have the calculations for the free fall, and from there we start making the calculations for three values of k. Now, if the acceleration is given in meters per second squared, I have meters per second here, that means that the units for k are 1/seconds. So the time for the free fall here, this is the time from release to the moment in which the falling body reaches the ground. Is for y from 1000 to y equals from y equals 1000 to y equals 0. Now remember that this is equal to 2 times h divided by g. And that gives us 14.2857, 14.286 seconds for h equals, or y0 equals 1000, or y0 equaling 1000 meters. Okay, so for the free fall, we calculate the values for the velocity and for the position, so that we can have, we know that the acceleration is constant for the free fall, which will be 9.8 meters per second squared. So for acceleration, we have this straight horizontal line on for the graph of a versus t for the free fall. This corresponds to the blue line. And for the velocity, we know that the formula for the velocity should be, remembering that the value of v0, that is the initial velocity, is 0 meters per second because the uh, the body was let go from rest. So we have then that velocity or the free fall is given by minus 1 times g, which is 9.8 meters per second squared, and is the value of cell A68, which we write in this fashion so that as we go down column G, this cell reference remains unchanged. And F70 corresponds to the respective time value for cell F70. So this goes down, these values go down from 0 to the free fall time given in cell E68. Okay, so y equals then the initial height which is given by the value in cell D68, which is this one, minus 1/2 of A68, which is G, this one, times the respective value of time squared. So this is the way you can either write the squared as the circumflex 2 or double asterisk 2. Okay, so now we calculate the values for velocity and position for k equals 0.01 per second, or 1/seconds. So here we have the formula for the velocity, so which we use this expression here, minus g over k times 1 minus exponential of minus kt, which is what you see here, minus, this is g, and B68 is the value of k, B68, which corresponds to 0.01. Remember that we have the dollar signs to indicate that these cell references must be left unchanged, times 1 minus exponential of minus kt. You can see, as before, we drag down the fill handle, remember, down to the value of time such that when we check up the height or the position, the height above ground, we can get as close to 0 as possible. You can change this value if you want to, this last value here, if you want to get a better approximation to 0. For example, if you want to have this. Okay, here we've passed the proper value. Here we've also passed the proper value. Here we've gotten much closer. And here we even got even closer. So here we are close enough. This is 0.001, that's meters. That's about 2 millimeters from the ground. That's about 1 millimeter. So here we are less than 1 millimeter from the ground. So we can leave it there. It won't change the graph, the respective graph much. Here I just saved the file. The file still hasn't changed. Okay. So let's check the plot. As before, well, you won't be able to appreciate the change I just made to the last value of time on the graph of y versus t. But we have a better approximation to the ground. Okay, we'll continue with this discussion on the next video.